So, welcome to this introduction to multi-threading class. So, we are going to talk about, subsequently, we've treated thread, like the process of splitting your task into different threads in your computer. That we have main process that you can split into other sub processes, and we also talk about there are different types of thread. We have the daemon thread, or which I also call the auxiliary thread, and we have the main user thread, which are user defined, even including the main thread. And all those daemon thread, they automatically shut down immediately all the user tasks have completed. Those are what we've been doing. So today we want to delve deeper and go into multi-threading core. And they say, okay, this program you're writing is multi-threaded. What is it about? We're going to get into the introduction basically. So multithreading is a key concept in modern programming that allows a program to perform multiple tasks simultaneously. Like we have seen, this improves the efficiency and performance of a system by utilizing multi-CPU cores. I showed you the other time that some people's CPU here are 8, some are 4, some have even 16 CPU that I have seen, and some is just single or double core, quad core, dual core, penta. I don't know if there is penta. I know there is. What is octa core? What is 16? If 4 is quad core, 8 is octa core, 16 is what? Octa double. You say what? Okay, hexadecimal core. Abi? Alright. I don't know if that exists. I don't know that that's the name they call it. Sometimes naming come to some places, they might change it a little. But what am I saying here? All those plenty cores. If you don't multi-thread your program, it is still going to use only one of them, right? So that's the whole process. So in the context of Java, multi-threading enables multiple threads to run concurrently with the same program. That is the same program you're writing. Plenty things are happening at the same time. So threads, as the smallest unit of execution, allow a program to be more responsive and efficient by distributing the workload. So you have the multiple threading, split them into thread 1, thread 2, thread 3. This one is doing this one is doing that, and that. So all of them are performing their tasks to make all the tasks, to make them work better. Multitasking, splitting the workload. So in this subsection, we'll be defining multi-threading, explaining the benefits, and introducing key concepts such as synchronization and inter-process communication. Synchronization and what? Inter-process communication. So by the end of this session, we should understand how multi-threading improves application performance and how to use it in real life programming tasks. So the objective of the class, at the end of this session, we should be able to define multi-threading. They ask us, define multi-threading. Captain, you are laughing on top of your phone. If they ask you, define multi-threading, you should be able to comfortably say it. This is the objective. At the end of this class, if you don't meet this objective, make sure you ask question, because we'll still reference this objective. This note, it's in your book, just that I shorten it. You need this shortened version. Alright. I'm trying to load them up to link. I have not completed it. Sorry. I'll send you a link. Explain the need for synchronization in a multi-threaded environment. Why do we even need that multi-threaded? The need for synchronization. There's something called synchronization. You understand? We have talked about asynchronous programming, and that's what brought about what multi-threading in the first case. Why do we still even need synchronization? One thing happening in one thread. Okay, please come in. Okay, wait 1 minute, please. So, sorry about the little bit of distraction. So, we are talking about the objective. Say the major purpose of multi-threading is asynchronization. You don't want them to happen independently. Synchronization is directly opposite. Awaiting something to happen before the other to happen. That's what is the need for synchronization in a multi-threaded environment. We want to captain. Then you must be able to explain this. And also at the end, you must be able to understand inter-process communication, how process communicates, right? That's the objective of this subsection. So, and how it works within threads. If I ask you how, or give a scenario and ask you, should be able to tell me. So we will be working step by step. Make sure if the whole process of learning does not align to this objective, you better raise alarm. You understand? Alright, so illustrate the concept of concurrency and its importance in Java application. Then develop a basic multi-threading program to execute multitask concurrently. So multi-threading is a type of concurrent programming where multiple threads run in parallel, enabling a program to handle more tasks at once. In single-threaded program, the CPU executes a task at a time, which can be inefficient, especially if one task is waiting for a resource. Example, user input or network communication. It's waiting. Multithreading overcomes this limitation by allowing the CPU to process multiple threads simultaneously, improving the overall throughput. So Java provides robust support for multithreading through its thread class and runnable interface, like we have seen, allowing developers to create and manage thread with what? What are you? Oh, okay. So, however, these are the two things Java provides to make it robust, right? The thread class and the runnable interface, allowing developers to create and manage threads with ease with these tools. Thread can be executed concurrently, and Program's task can be divided into smaller manageable parts that runs independently. However, with the multi-threading comes with challenges of managing access to shared resource. Without proper synchronization, multiple threads accessing shared resource can cause conflict and inconsistent results. The same account balance, somebody is transferring, you are withdrawing. You understand? Somebody is transferring, you are withdrawing, and something else is happening, plenty things. So this is where synchronization comes into play, ensuring that only one thread can access a critical section of a code at a time. So in a use case, let's talk about web servers. A web server uses multi-threading to handle multiple requests at the same time. Each incoming HTTP request is assigned a separate thread. We have get request, post request, put request, delete request, each of them coming with their own thread, allowing the server to process multiple requests concurrently without waiting for one request to finish before handling the next. So in real-time systems like operating systems, embedded systems, and even video games, multi-threading is used to ensure that critical tasks such as monitoring user input or even rendering graphics continue while other tasks are processed in the background. In file processing applications, I don't know, like maybe Photoshop, I don't know. In file processing application, multi-threading can be used to handle multiple file operations concurrently. For example, one thread can read a file while another thread processes it, and a third thread writes and input the output, increasing efficiency. So in real world scenario, banking application. In a banking system, multi-threading can be used to process multiple transactions at once. For example, while one thread is handling a deposit, another thread can simultaneously process withdrawal. This ensures that users do not have to wait for one transaction to complete before starting another, enhancing responsiveness of the system. Online shopping. In an online shopping system, multiple users may be browsing the site, adding items to cart, and checking out at the same time. Multi-threading enables the server to process each user's request independently, improving user experience and making the system more scalable. So let's talk about some example, basic concept. This example will help us understand fundamental concept of multi-threading. We'll create a simple Java program with 2 threads that print numbers concurrently. We have done this before, but we are still going to do it again. So let's create a class called print numbers, which extend thread as usual. So I'm going to create my Java file. I'm going to call it main.java because I'm going to make it a public class. And it's main. Oh no, not function. Public class, public, and it's public class, main, not main. So it has a main function inside. Public static main inside. Then that's that. Control B. Let's all see it. And after that, I'm going to create a main thread. This is our process. This is the one that is going to be the thread class, extend the thread class that we'll be using in our main class. So basically what it's doing is looping between 1 to 5, less than or equal to 5, and printing each of those numbers and sleeping for half a second. That's what it's doing. So quickly we are going to do that counting. So we create a class called another class. This is not public. I'm going to call it what do we call it there? We call it print numbers. Print numbers. It's just a class. It extends the thread class. Extends the what? Thread class. This is what we've been doing. We are used to this already. Then aside this, there is because it's extending the thread class, it has to Ctrl Z. So run the run function. We're overriding it. So what does the run function do? It's inside it we have a for loop. The for counts between int I, which is equal to 1, to what? I is less than or equal to what? Less than or equal to 5. Then what? We are increasing I by 1. I plus plus. Then in this loop, in each loop, we want to print just print south, just that I. Yes, ma'am. Then sleep for half a second. That we do what? Thread.sleep. For how many seconds? 500 seconds. Then but remember we must wrap it in try catch, right? Because it's so in case there is any exception, we throw what? Interrupted exception, and we print the stack trace. This is just this. So quickly, let me answer that. not replied the mail from Aptech for the project. We'll talk about that later. But if you have not replied, do well to reply to them. So this is the thread class we'll be using. This is the runnable. This is the task we want to be running. So this is how you remember how to create an instance of it. The objects we want to create is of the type print number. This is how we create objects, and we'll call it task. We can call it task 1 or whatever name you want to call it, and it's equal to a new word and the statement. You have created a new object. So how many objects do I want us to create? 2, and we'll start each of them independently. So this is task 1, and this is what task 2, and task 1 does start, task 2 does start abi. To start it on a new thread, remember. Then task 2 dot start. Let's run it. Then run it like this. Okay, is it running? What's everything? Okay, it's not on the debug console. It's running. Oh yeah, it's run. So 1, 2, 3, 4, 5, all of them are just doing their thing. So we could even make let's not go with the more customization. Let's go straight to the, because we are already out of time. So that's that. The explanation is simple. We've known that this program creates 2 threads that both print numbers 1 towards 5. The thread.sleep method simulates a delay which actually make the thread to sleep for some couple of seconds, which is half a second, 500 milliseconds, which allows those other threads to even execute. Then by calling start on each thread, they begin executing concurrently. Let's talk about the example is to demonstrate the need for synchronization. The need for synchronization when multiple threads access shared resource. This is the next example. Task: we are going to simulate 2 threads that both increment a shared count variable. Right? All of them are not managing each internal state on their own. They are managing one state. So without synchronization, we may encounter inconsistent results. So for example, let's have a class called counter. This counter has an int state called 0, which is count, which is of the value 0. Then a public setter that increments it by 1. If we say increment, it adds 1 to it. So I'm going to create, I'm going to take this print counter out quickly just for demonstration purpose. I'm going to take all this jargon now. I'm going to create a class. Is it public? It's going to be public, right? It's just a class called counter. It takes in count and an increment function. So class counter. It has an internal state of integer which is called counter, and its initial value is what? 0. And it has a void function. It's a public class that will be accessed outside this class, public, and we don't have to return anything. And the function name is called what? Increment. Okay, thank you. What is this? Oh, sorry, don't worry. So increment does not take any value. It's only till the. In fact, let's make this thing static because it belongs to the class. It's public static. We talked about different types of public static. Abi. Let's int. A static class belongs to the class, right? If it's int, let's leave it like that. So is this let's just leave it like this first. So just towards counter plus plus. Anytime anybody calls this function, it's only increase counter by 1. That's just that. Then there are 3 threads, 3 classes. Number 1, increment thread. This is where we want to do the main task, one task. Can we see it like this? Let's do this one. You see? Okay. So create a class called increment thread, which extend thread and has a counter object, and increment thread, which is a constructor. It takes in what? It's an object that accepts the counter object. Then what? Sets the counter towards counter. So this increment thread, it takes in a counter object which will be defined, and anytime you add that counter object into it, it takes the counter and it sets that counter. That is just like a constructor. Then the actual action that this thing is performing on this counter is anytime the run or the start starts running, it's count from 1 to 0 towards 999, and count dot increment, and it increase that count. So in case we create this thread, it will be fitting on this same count. Let's quickly go and do quickly. So let's create another object, increment counter class, increment first. It has it has a counter type state called counter, and then it has a constructor which is public, and it's increment counter, which takes a counter type called counter, and it sets this dot counter to be the counter that is passed in that statement. Then after that is just the constructor. In a run, oh, it's going to extend what? The thread, for us to use that word runnable thread. It's going to what? Add extends here. So it's going to extend thread, because we want to use the run class. So this run, it has a loop inside that counts from, that takes the counter and counts, so it's a for loop. For that counts from int I, initial I is what, equal to 0, I is less than 1000, then I plus plus. Then what are we really doing? Whatever it is, we take counter dot whatever is the object of counter that we have. There is this this object that we had to counter dot increment, that is to increase it, which was defined here. So the counter so this function is going to increase the counter that is passed in. So any counter can be passed in at all, but whatever counter that was there, increments that counter. Whether the counter has a value of 5, has a value of 0, increment that counter in this same thread. Now let's talk about, are we done with this class? Let's all write this class. Then we go to synchronization. You're a wise man. Can you say like this?
Three threads give two assets. Number one, the objective of this success. So and how it works within threads. If I ask you how, or if there is Siberia and ask you, should be able to tell me. So we'll be working it step by step. Make sure if the whole process of learning does not align to this objective, you better raise alarm. You understand? Alright. So illustrate the concept of concurrency and its importance in Java application. Now develop a basic multi-threading program to execute multitask concurrently. So multi-threading is a type of concurrent programming where multiple threads run in parallel, enabling the program to handle more tasks at once. In single-threaded program, the CPU executes the task at a time, which can be inefficient, especially if one task is waiting for a resource. Example, user input or network communication. Multithreading overcomes this limitation by allowing the CPU to process multiple threads simultaneously, improving the overall throughput. So Java provides robust support for multithreading through its thread class and runnable interface, like we have said, allowing developers to create and manage threads. What?
So how are we now? To recall where we are, we have made three class, the main class, which we have not done anything there, a counter class which we are going to create object for it. This is the shared resource that we have created, a shared resource that has a state and a method, a field and a method, right? The field it has is called counter. Then counter, that's it. Then it has what? The method, this method called increment. Help open that door for him, please. So now we created this runnable this thread class that help us to.
You are withdrawing. You understand? Somebody is transferring, you are withdrawing, and something else is happening, plenty things. So this is where synchronization comes into play, ensuring that only one thread can access a critical section of your code. So in a use case, let's talk about web servers. A web server uses multi-threading to handle multiple requests at the same time. Each incoming HTTP request is assigned a separate thread. We have GET request, POST request, PUT request, delete request, each of them coming with their own thread, allowing the server to process multiple requests concurrently without waiting for one request to finish before handling the next. So in real-time systems like operating systems, embedded systems, and even video games, multi-threading is used to ensure that critical tasks such as monitoring user input or even rendering graphics continue while other tasks are processed in the background.
So we're good to go, right? Now let's create the
In file processing application, multi-threading can be used to handle multiple file operations concurrently. For example, one thread can read a file while another thread processes it, and a third thread writes and prints the output, increasing efficiency.
So now we have created three classes. Number one, a counter class, which we are going to be using to mimic our shared resource. It could be a file that has a data inside and some method inside, or any object. Then it could be in single value. It could be anything. But this counter class is going to act as our what? Shared resource. Now we are going to talk about synchronization. So quickly, let's create that class called synchronization. I'm going to close this plenty instance of outside and increase the form we've made for counter, we've made for increment. Now let's make for for synchronization. We're going to happen inside. So inside our main class, we'll create an object called counter, object of counter, and create two threads from that increment thread. Then we start the thread, and remember, when you are creating that thread, it has a constructor that takes in what? A counter object. So we pass in only that single counter, which is the shared resource, right, among those two of them. And when we start them, we try and thread 1 dot join, thread 2 dot join, just to merge it to this parent thread and catch interruption. This, you remember join? Will you talk about join? What does join method do? Let's continue our function. Let's create a new, inside our main, let's create a new object of the counter class called counter, and we'll call it counter. We can call it any name, or we can call it shared counter, which is actually a new what? Counter. New counter. We end that statement. Then we create a new instance of those two threads, which is of what do we call it? Increment thread, increment counter. So an increment counter object called task 1. Yeah, let's go. Let's see. So increment task 1, then we'll create another task, increment task 2. Quickly, let's create these two tasks inside it, and I'm going to call this task 2. Define it again. Let's see. Join. So sorry. Somebody tell me how they do that. Jemima, how did you do this keyboard that? If I have typing, if it's swiping everything in the front, what do you press that time? Here. Where is insert? Okay. Oh, thank you. So equal to new. Now start both of them. So task 1 dot start, then task 2 dot start, and let's run it. This is what we conventionally meant to get. Sharing the same resource. How many? Just count. Just is that okay? Does it print? We didn't print anything. How did we do? Just increment task. Should be able to display our outputs. Where we are displaying after south print final count, the count after everything. So without this, quickly after this, let's just sound the counter dot count. Let's just see out. Let's view after everything south. Shared dot counter, and you get the value. Let's run it now. Let's print it and let's see. If you run it, it is 0 because we didn't wait. So remember what did you define it again? The join help us to wait for a thread, right? Watch this. Captain, what are you so engulfing? Like they are even calling your name. You are so delved in so deep. They are even smiling at it. Are you playing with the headset earpiece and laughing? I'm calling your name. Say what was the definition you make again? You made.
The join method in Java is using multithreading to make one thread wait for another thread to finish before continuing.
We did not ask the main thread to wait. So if you run this thing and we print out this shared resource dot count, you will see that it will return 0, which is the initial value, right? We should find a way to wait for these two process to finish running first. Then we join them. That is why we join, right? So we are going to try the joining by saying we must wrap it inside try catch, of course, for uninterrupted exception. So if you see task 1 dot join without it will throw that error. So you can always wrap it with try catch. Then we want to join both task 1 and task 2 to the main, because this is the main thread happening here. We are printing stack trees, so we are not expecting 0 after this. If you run this anymore, you're expecting what? 2000, because the process was run independently. Eh? Back down. All right. It's okay.
say what was the definition we make again? We make thread class that help us session purpose. I'm going to call this I'm going to create a public class. It's a public key. It's going to be a public key. It's just a class called counter. It takes in count directory information. So class counter. It has an internal state of integer which is called counter, and its initial value is what? 0. And it has a void function. It's a public class that will be accessed outside this class scope. You don't have to return anything. The function name is called what? Increment.
We're good to go, right?
Sorry, go on.
So let's just pause here today. That's just about that. We'll continue this next time. So explanation here, two threads are incrementing a shared count variable. Without synchronization, both threads may read and write to count
Okay, start.
variables simultaneously, causing inconsistency. So to fix this, we would always add the synchronizing keyword in the increment method. So ensuring that only one thread is doing the count. So let's just leave this till next class, and for now,
Just what?
this note was
Counter clusters.
what question? Any question?
Only replace and count.
Okay.
There are three
Okay,
threads
I should
in
ask
class.
questions now.
Number one,
We're already out of time.
increment thread. This one
Let's
is
continue next class tomorrow.
one part.
So
Can we see?
read your books, get conversant with this concept, and let's end the class. All right, see you tomorrow.